Welcome back to this series of 6 videos about the division by zero. The fourth part in the series deals with the ring of metacomplex numbers. We will examine several properties of the set of metacomplex numbers in combination with addition and multiplication, and we'll be able to conclude that we are dealing with a commutative ring with unity. The first property under investigation is closure under addition. In the previous video, we already saw that when we add two metacomplex numbers together, we obtain another metacomplex number. Therefore, we can say that the set M of metacomplex numbers is closed under addition. In the same way, the set M is closed under multiplication. When we multiply two metacomplex numbers together, the result is again a metacomplex number. Here you can clearly see that the product of M1 and M2 has the form of a metacomplex number, with a real part A1, A2 minus B1, B2, an imaginary part A1, B2 plus A2, B1, a zero part A1C2 plus A2C1 minus B1D2 minus B2D1 plus C1C2 minus D1D2, and a meta part A1D2 plus A2D1 plus B1C2 plus B2C1 plus C1D2 plus C2D1. Therefore, the set M is closed under multiplication. The next property is the associativity of addition and multiplication. Let's first consider addition. When we add three metacomplex numbers, M1, M2, and M3 together, it doesn't matter in which order we do it. We can either first add M1 plus M2, in parentheses, and then add M3 to that, or add the sum of M2 and M3 to M1. We can also simply omit the parentheses and always obtain the same result. You can verify this for yourself if you want. Similarly, the multiplication of three metacomplex numbers M1, M2, and M3 yields the same result, whether we first multiply M1 by M2 and then multiply the result by M3, or multiply M1 by the first computed result of the product of M2 and M3. Here too, the brackets can be omitted. Therefore, addition and multiplication are said to be associative in the set of metacomplex numbers. The next property is not a necessary condition to have a ring structure, but it applies to the set M nevertheless. The commutativity of both addition and multiplication. It is not difficult to ascertain that the order of addition of two metacomplex numbers, M1 and M2, has no impact on the result. M1 plus M2 yields the same result as M2 plus M1. Therefore, the addition of metacomplex numbers is said to be commutative. The same applies to the multiplication of metacomplex numbers. M1 times M2 is equals to M2 times M1. Here too, the order of operations is inconsequential. Thus, the multiplication of metacomplex numbers is also commutative. The set M has an additive identity element, that is, a number that can be added to any metacomplex number and results in the same metacomplex number, so it doesn't change the number at all. The additive identity element in M is 0 plus 0i plus 0z plus 0iz, or simply 0. A metacomplex number where all the coefficients are 0. When we add this number 0 to the number a plus bi plus cz plus diz, that number remains unchanged. The set M also has a multiplicative identity element. That is the real number 1, which is 1 plus 0i plus 0z plus 0iz. When we multiply any meta-complex number by 1, the number remains unchanged. Next up, the additive inverse in the set M. The additive inverse of a meta-complex number M is the meta-complex number that, when added to the original meta-complex number M, yields the additive identity element 0. Every meta-complex number A plus BI plus CZ plus DIZ has an additive inverse, which is minus A minus BI minus CZ minus DIZ. This can also be written as minus between brackets A plus BI plus CZ plus DIZ. As can be seen here and can easily be checked if you want, the sum of the two numbers is 0, the additive identity element. And finally, the set M also has the property of distributivity of multiplication and addition. This is written as M1 times between brackets M2 plus M3 is equal to M1 times M2 plus M1 times M3. As a result of all those properties, we can conclude that the set of meta-complex numbers M with addition and multiplication forms a commutative ring with unity. Here you can see all these properties summarized. And that brings us to the end of this video. The link to an article I wrote about division by zero can be found in the description below. And please leave your comments in the comments section below. Thank you for watching.